All right, so setting that up is the geometry, right? Okay. If we cross multiply, we're going to get y squared. Now, this is kind of a pain in the butt to cross multiply this way. What should I do with these two numbers? Add them together, right? What do you need to add fractions? Common denominator. So 1/3 is the same thing as 2/6. Now I add those together and I get 3/6, which better written as 1/2. So now when I cross multiply, what's 1/2 times 1/6? Nope. When I go 1/2 times 1/6, that's the easiest rule for fractions that you'll ever come across. Straight across top, you multiply, and what's 1 times 1? And then straight across the bottom. So 1/2 times 1/6 is 1/12. Square root it, so I get this. Correct? Okay, now, because it's the same rule that allows, so if I had like 2 times 12 underneath the radical like that, we could do this, right? We could break it up. Well, same thing happens in division. You can break up the numerator and the denominator, put them on their own radicals. Okay? Because this number right here, guys, what we're going to do later, we want this y value so we can do something else. So we can do a further calculation. Okay? Maybe we're looking for the area of this triangle, and I would need y to do that. Okay? Well, plugging in radical 1/12 into my formula for area is going to be a pain in the butt. Okay? So we like to kind of rewrite. For the same reason, let's say I have 8 divided by 4 as an answer. I'm going to take that 8 divided by 4 and I'm going to multiply it by something later, or divide it by something later. Well, do I want to use 8 divided by 4 or 8 over 4, or do I want to, with further operations, do just 2? That kind of makes sense? So when you're trying to find the answers, and you always ask the question, why do we have to simplify? It's because you're getting in the habit of taking a value, writing it in the most convenient, most appropriate way, so that when you use that value in another further calculation down the road, that calculation is as simple as possible. Okay? And it's set up using the most appropriate, most accessible values. Okay? So that being said, we don't like to leave fractions underneath radicals. And especially when I break it up as square root of 1 divided by square root of 12, we don't like leaving a radical in the denominator. Okay? You might have heard this word before, or this phrase. We are going to be rationalizing the denominator. Ever heard that before? Rationalizing a denominator. Okay?
Wait, so what happens if you don't simplify the 1/2? You do 3/6.
So then you'll get 3 over 36, right? So that, I mean, that works in this case, but there will be times where maybe that doesn't necessarily work out that way. What I want you guys to, I'm trying to show you that this algebra is used everywhere, a lot of other places, and it's going to be important for us to be able to rationalize it regardless. Does that make sense? Your technique is going to work, and I'll show that here in a moment. But we also want to be able to do this in case these numbers didn't work, if these denominators weren't the same. Does that make sense? So rationalizing the denominators here, the key word here is rational. Okay? Basically what it means is you're taking this number with the square root of 12 is an irrational number, right? Okay? Meaning that its decimal does not repeat and it does not end. Okay? We're going to do some work here that turns it into a number in which it does terminate or it does repeat. A rational number is anything that can be written as A over B, where A and B are integers. Okay? Z is we use that letter Z to represent the list of integers. Okay? So that's what we're going to try to do here. Okay, we're trying to get this to be a rational number, not an irrational number. And the way you do that, it's real simple. You multiply by 1. Okay, we're going to multiply by 1. But it's not just putting 1 over 1, because that's going to give me the exact same thing that I have, right? I'm going to multiply by what we call a convenient value of 1. Is that still 1? Radical 12 over radical 12? Okay. Now, why I chose radical 12 is because it was what was here. You always take that denominator and multiply by itself over itself. So now what happens when I take radical 1 times radical 12? Does anybody know what radical 1 times radical 12 is? It's radical 12. Okay. What's radical 1 the same as? What's the square root of 1? 1. So 1 times anything is that anything, right? Okay. We'll talk about multiplying radicals here in a little bit as well. What's radical 12 times radical 12? Radical 144, which I heard somebody say 12, right? And this number, which was irrational, now become rational? Yeah. It's 12 over 1, right? It's an A over B where A and B are both integers. Okay? So we just rationalize that denominator. Now, that's not the answer yet. Okay? Because is there a perfect square inside of this 12 that will divide it evenly? Okay, so what's that perfect square inside of 12? I'm sorry I ran out of room here. I'm going to go this way. Doesn't 12 break down to radical 4 times radical 3? Does that make sense to everybody? What is radical 4 the same as? 2. Now what we've got here, think about this. We have 2 times 3 divided by 12. Okay? If you guys had, let's say, because I think it's easier to draw comparisons between just rational numbers instead of rational and irrational. If I had like 2 times 3 over 12, and you did order of operations in the numerator, you got 6 over 12. That would give you a half, right? Okay. I don't know what that was all about. If I had 2 times 3 over 12 this way, okay. Now, what if I took these two and wrote it as 2/12 times 3? What's 2/12? 1/6 is 1/6 times 3, 3 over 6, which is still 1/2. Does that make sense, everybody? So what we can do when we have products in the numerator, we can take either 2 over 12 times radical 3, because if I write it that way, what's the denominator right now for radical 3? 1. And if I multiply these two fractions, wouldn't that give me 2 radical 3 over 12 times 1, which is just 12, right? Does that make sense? Okay. Or you could break it up, you wouldn't do this, but you could break it up as 2 times root 3 over 12. Now, the reason I want to do that is because if I can pair up rational numbers with rational numbers through division, that's what I want to do. Here I've paired up an irrational with a rational, and I don't have any cancellation occurring. But I can rewrite this as 2 over 12 times radical 3. Well, what's 2 over 12 reduced to? 1/6. And now doing my multiplication, 1 times radical 3 is radical 3. 6 times 1 is 6. So that's how we take that number right there is a better version of that number right there. Okay. Now, this is just a coincidence because of how the 3 and the 6 are multiples of one another. And really the same thing with the 2 and the 6 here. But Chandler said, what if we take the 1/3 and the 1/6, we added those together, and we got 3/6 over y is equal to y over 1/6, right? Cross multiply, you get y squared is equal to 3 over 36, isn't it? Does that make sense, everybody? Square root both sides now. And I'll get radical 3 over radical 36. What's radical 36? 6. Is that a much quicker way of getting to the answer? Yeah. And that's something that you guys got to pay attention to. And always talking about don't be robotic. Always foreshadow. Think about what is the math going to do for me. If I know I'm going to take square roots, and I've got my fractions written this way, it might be useful to leave it this way because the square that product doesn't create perfect squares for me. But that being said, what if for some reason, I don't know, that was like a half. Now I get 3/12, so I gotta go do what we did over there, right? So both approaches are fine in that question. The one I showed on the smartboard will always get you your answer. And in other areas of mathematics, you're going to have to use that process. Okay? So you do the same thing then for z and the same thing for x with those values. Somebody say I want to see 12? We'll talk about 12? I'll help you write the proportions. And this is where people struggle. That's a leg, right? And it can go here, and it can go there. It has to. That's where legs go. Okay? I think we get in the mind for, especially maybe with the first handful of questions, these were always variable components, right? They don't have to be. It's legs. Okay, whatever is being used to represent the leg, whether it's a number, a variable, expression, whatever. Okay? Now, it's the geometric mean then between the entire hypotenuse, right? So that would be 15. And now what part of the hypotenuse is touching the leg of 9? X. Okay, so that's going to give you a fraction back. You can write it. It's a terminating decimal, so if you want to write it as a decimal, it's fine. I don't care. But now that I know what X is, let's say, this is wrong, but let's say X is 7. What's Y? 8. And now do you have the components necessary to find Z? Yeah, I can say Z is geometric mean between 7 and 8, right? I'm not sure what X is. It's 81 over 15, which is what, 27 over 5? Okay. So whatever that ends up being as a decimal, 5.4. Okay. 15 minus 5.4, then we'll give you your Y. Is that doable? Okay. That's really the only one that decimals were really appropriate for. 14. 14's got some algebra here that, again, we're probably not big fans of. Okay. Before we get through this, let's write this down first. If I'm multiplying radicals, I'll give you a generic rule here. It says if you have A radical B times C radical D, where A, B, C, D are real numbers. Okay, so anything they want to be. Okay. To get the product of those two things, you take, your result is AC on the outside, BD on the inside. Now chances are BD will need reduced. Okay. For instance, if I had like 2 radical 3 times 2 radical, try to figure one out here. 15. Take the numbers on the outside. 2 times 2 gives you 4, right? Numbers on the inside. 3 times 15 gives you 45. But now that I created this 45, that's a composite number now, right? Sort of a larger composite number. Is there a prime number that, a perfect square that will divide 45? Is it 45 that product? So what's the square root of 9? 3. So I got 4 times 3, which would be 12. 12 and then radical 5. So that's how you would multiply radicals, right? Okay. If I am adding or subtracting radicals, okay, we're going to have A radical B. I'm just going to write plus because I'm just adding the opposite. That would be subtraction, so it doesn't really matter. So we're going to A radical B plus C radical B. Okay? What do you notice about what I've put in here? They are what? They're the same. They have to be the same in order to add these. Okay? Where A, B, and C are still following that rule there. All you do then, that should equate to A plus C. Add the numbers on the outside, and then multiply by radical B. So if I have 2 radical 3 plus 5 radical 3, would you agree that the 3's are the same? So you take the numbers out front, 2 and 5, it gives you 7, right? And then radical 3. You guys remember doing some of that stuff last year? All right, so here's a question then. If you remember doing that, then you should remember when somebody gave you like 2 radical 3 plus 4 radical 5. And you write that as what? What's the key thing here? Are they the same? So this is how you write that sum. Okay? You cannot condense it. It's like saying I'm taking x and x squared and adding those together. Or it's like I'm taking x and y and trying to add those together. You can't, right? If I have 2x plus 3y, I just write it as 2x plus 3y. I don't write it as like 5xy or something like that. Okay? You cannot add radicals together that have unlike radicals. Okay? So the radical, the number on the inside has to be the same for you to add and subtract. Is that doable? Okay. So those are the rules that you need to know to really progress through this question. If let's just look at y. So I want to find y. And actually, we might have to, I don't know. We might have to come up with all the proportions here. That might be something we want to do here. If I go y and y, this would be x plus square root of 2, right? It's the whole hypotenuse. And what's going to go here? X. Okay? That's a pain in the butt to deal with, right? Multiple variables. So go find another proportion. Let's deal with z. Z here, z there, right? What could go here? If I'm looking at that as the geometric mean, x, and then what's here? Radical 2. Now I'm going to look at, because that's still 2 variables, right? Look at the last proportion, and that deals with that side there, right? So I can put a number here and here, right? That's fine. Now what would the hypotenuse here be? X plus radical 2. So that's the whole hypotenuse. And now what part of the hypotenuse is touching this 2? Radical 2. Okay. Does that have one variable? Can you solve for it? All right, so let's do that. Let's go. Cross multiply. 2 times 2 is 4. So there's my means. Now, understand radical 2 is just a number, right? Anytime you see a radical, it's just a number. So if that was like 5, you would take 5 times x, right? And then 5 times the radical 2, right? So let's do the same thing. It's just radical 2. So we'll go radical 2 times x. I'm going to write it this way first, but then I'm going to erase that and write it a different way, because that kind of stinks. So I distribute the radical 2 to that, and now I distribute to the radical 2. So what's radical 2 times radical 2? It's 2, right? Numbers on the outside, so you get this 1 out here and this 1 out here, so you multiply them together, you get 1 on the outside. And then numbers on the inside, 2 times 2 gives me 4, right? The radical 4 simplifies to 2. Now, writing this one here the way I did, just notation-wise, it develops confusion sometimes with whether that x should be underneath the radical or not. So the way we eliminate the confusion is we just write the radical out, the variable out front. So now there's no confusion of whether that should be under there. Does that make sense, everybody? But the radical 2 is just a coefficient. It's like a coefficient of like 1.414, but it goes on forever and never ends, so I can't fully write that coefficient. Does that make sense? So I have to use the symbol to do that. So how do I start isolating the variable? Subtract 2 from both sides, right? Gives me that. I'm going to write this real quick. 2 equals, don't write this down, but 1414 like x. That's what 2 equals x square root of 2 is saying. If I was looking at that one with the decimal on the right hand side, what would you divide both sides by? 1.414, right? So if I was going to divide by 1.414 over here, I better divide by that same thing over here, right? That radical 2 is this number. It's just a better version of it because there's no rounding taking place. So divide by radical 2 over radical 2. Those go away. Come over here, divide by radical 2. So now, that's going to give me 2 over radical 2 is equal to x, right? Do I like that answer? So what do I need to multiply by? Radical 2 over radical 2, right? Multiply by that version of 1. So it gives me 2 radical 2 over 2, right? What do you notice about those 2's? Can I write this as 2 over 2 times radical 2? And 2 over 2 is the same thing as 1, right? Won't they cancel? So that number right there, 2 divided by radical 2, is the same thing as radical 2. Now think about why we would want to do this. Why would I want to rationalize? If I want to find y and z, I need x, right? Would you rather put radical 2 here and then add that to radical 2? Or would you rather put 2 over radical 2 and then try to add that with radical 2? You'd rather put this red one, wouldn't you? It makes more sense. It's easier to do. Okay? If I was multiplying, so I'm going to put x right here, it's radical 2. Does that multiplication look a little bit easier than that multiplication? It will produce the same result, just in different formats. And we'd rather it be radical 2 instead of 2 over radical 2. Okay? I'm going to stop there with that. You guys have till Friday. We talk about some more of that tomorrow. But I want to get to a quick set of notes from 7.5.